Check it.
Okay, welcome back. Today we're going to be doing day 2 of lesson 1.6, absolute value inequalities. So the same as what we did yesterday, except now we're going to put absolute values into them. Before we get started, let's just do a couple of Algebra 1 warm-ups here. So from Algebra 1, you know that you can solve an equation, meaning get the x by itself, by getting rid of everything except for the x. So we'll get rid of this negative 3 here by adding 3 to both sides, right? This is called reverse PEMDAS. You start with the adding and subtracting, and then you finish with the multiplying and dividing. And then lastly, we'll divide by 2 here, right? And we get x equals 6. So that's, Algebra 1 all done. But another thing you learned in Algebra 1 was how to find the absolute value of a number. And if you remember, an absolute value was the distance from 0. So if you have a number line, and here's 0, what number has a distance from 0 of 3? Well, obviously 3, 1, 2, 3, because if you go 3 to the right, you'll get to 3. But also negative 3. If you go negative 3, if you go this way, 1, 2, 3 to the left, you'll also have a distance of 3. So if you're walking, okay, Abraham Lincoln with a top hat, I don't know. If you're walking from 0 to 3, you're taking 3 steps. And if you're walking to negative 3, you're also taking 3 steps. And since there's no such thing as a negative step, they both work. So you actually get 2 answers. X equals 3 or x equals negative 3. All right, you get 2 answers here. That's simple enough when you have something as simple as that, but what if you have to actually solve something here? Now, you could sit here and guess and check and plug in numbers to see what works, but that would take a long time. So what we do is, if we have an absolute value, we realize that, like here, we realize that this absolute value equals 3, which means the thing inside had to either equal 3 or it had to be a negative 3. So here we're saying that the absolute value of this is 9, which means that this thing right here has to equal either 9 or negative 9, because once again, if you walk to the right 9 spaces or you walk to the left 9 spaces, it's the same thing, right? So you can break this up into 2 separate situations. And what I like to do is draw a big T, okay, a big kind of separator bar here, if you will. And what this will do is remind me that I have to solve 2 equations, not just 1. So, once again, like I said, this thing here has to equal either 9 or negative 9. So I'm going to write out 2 separate equations here. 2x minus 3 equals 9, and 2x minus 3 equals, and this is the other part, negative 9. Because remember, walking to the right or walking to the left, both of them are valid, both of them require an answer. So you solve each one of these individually here. See, we're going to add 3 to get rid of this negative 3 here, and we get 2x equals 12, and we get x, divide both sides by 2, you get x equals 6. That's one of the answers. But what about here? We're going to add 3, and we get 2x equals negative 9 plus 3 is the same as 3 minus 9. It's negative 6. And divide both sides by 2, we get x equals negative 3. So we get 2 answers, x equals 6, and we get x equals negative 3. 2 answers for an absolute value problem. All right. Now, this last one here, it's probably as ambitious as absolute value problems get. It's got a lot of stuff going on here. And you notice there's stuff happening outside of the bars. Okay. There's a plus 4 and there's a negative 2 outside of the absolute value. Okay. And now, in the last problem, what I did is I drew my t-bar like that. But here's the thing, you cannot draw your t-bar, you cannot split this into 2 separate parts until you get the absolute value bars isolated, until you get down to just the bars. So as long as this side of the equation here has stuff outside of the bars, you cannot split this yet. You cannot t-bar, if you will. You cannot t-bar yet. So what you do is you focus on getting rid of everything that's hanging out outside of the bars. Okay? So let's see, you have this 4 and you have this negative 2. Well, just like solving an equation above here when we had reverse FOIL, okay, we got rid of the thing that was subtracted and then we divided, right? So we add first, divide second, reverse PEMDAS. Well, here we're going to do the same thing. We're going to subtract this 4 first from both sides. And now we have the negative 2 times the absolute value of 2x minus 3 equals, and that's going to be, they're both negative, so add them together, use the common sign, negative 18. Now, how do you get rid of this negative 2? Well, you might be tempted to distribute. You can't do that, all right? You cannot get into absolute value bars whatsoever, okay? Think of them like prison bars. Nobody gets in, nobody gets out until you T-bar, and that's why you drop the bars. So what you can do, however, is divide the entire side of the equation by -2, and that'll cancel it out. But you cannot, do not, you may not, you cannot distribute into a set of absolute value bars. So you get there. Now we have the absolute value bars all by themselves, which is what we wanted, and this side is now +9. Can I T-bar yet? Yes. So what I tell students when I teach this in Algebra 1 is keep asking yourself, can I T-bar yet? Can I T-bar yet? So after we added the 4, can I T-bar yet? Not yet. Can I, you have to get rid of the 2, can I T-bar? You look at it now, you go, yes. Now, another thing you should do once you get ready to T-bar is to look at this side over here, okay? If this is an absolute value and nothing but an absolute value, this side has to be positive. When you've gotten the absolute value by itself, if this side is nothing but absolute value, it must be positive. It must equal a positive. So if you did have a negative here, you would say, oh, no solution. Okay? But only if you're ready to T-bar. Only if you've gotten it to the point where the absolute value bars are by themselves. But that's not happening here, so we don't need to worry about that right now. So then you go ahead and you split this up. Okay, 2x minus 3 equals 9, and 2x minus 3 equals -9. And if you notice, that's exactly the same stuff we had up here. So I'm not going to do the problems again. This is x equals 6, and this one was x equals -4. There are our two answers, just like, oh, sorry, -3, just like we had up there, up top there. Okay, so T-bar method is what I refer to it as. It's just solving absolute value equations, and you don't split into two parts. You don't T-bar until you get the absolute value part by itself. We didn't have to worry about that here, and we didn't have to worry about that here, okay? And I didn't technically T-bar this one, but you could. In other words, I could have very easily have done this and wrote x equals 3 and x equals -3, and I would have been done because there's nothing to solve at that point. You can just box your answers, okay? All right, so that was the quick Algebra 1 review. Let's get on to graphing absolute value inequalities, okay? So let's just get into it here. Okay, so now we have an absolute value inequality, all right? Similar to what we just did, except this time there's a less than here. But we're going to do basically the same thing. We're going to get the absolute value bars by itself before we can T-bar, right? So -1 will do the trick here. Now we have the absolute value bars by themselves. We have a less than, and we have a 9. Okay? So, can I T-bar now? Yes. So go ahead and draw your big old T, all right? Your big separator bar there. And what you're going to write on this side is everything here without the bars. So 2x minus 3 is less than 9. And on the other side, it's 2x minus 3 again, but this time, remember, on the right side, this number flips the sign. It becomes negative, so -9. But that's not the only thing that changes here. Another thing changes, which is not only do you flip the sign on the number, you also have to flip the inequality. So this less than on this side becomes a greater than. Those are two things you have to do. So up above, all I did was change the sign because that was an equation. For an inequality, you not only change the sign, you do change the sign, but you also have to flip the inequality. And now you have two inequalities that you have to solve individually. So add 3 to both sides. 2x is less than 12. Divide both sides by 2. You get x is less than 6. That's one inequality. Here, add 3 to both sides. Divide both sides by 2. So now you have two inequalities. All right? You have to graph these. This does say graph up here. Okay? So how do we do that? Well, we're going to take the two inequalities that we just found and put them on number lines. X is less than 6. Well, less than but not equal to, so that means we're going to have to use the end of the number line here because I don't have a 6. Open circle, okay, and shade to the left. X is greater than -3. Well, also open circle, because it's not underlined, right? And shade to the right. Okay, and there's that one. So you notice that there's no and there's no or here. So is this An and or an or inequality. And the fact is, you don't know until you've gotten this far. Once you've gotten this far and you've plotted the first two inequalities that you get from the absolute value, you look at them. If they're going towards each other, then it's an and. If they're going away from each other, it's an or. So you can see these two here. These are going towards each other. All right? So it's an and. And the way you graph it, you're going to have basically the overlap. So you bring down the circles. Remember, there's an open circle at 6. There's an open circle at -3. And it's everything headed, one's going to the left, one's going to the right. Okay, they're headed towards each other. This one's going to the right, this one's going to the left. And they're going to intersect in the middle. So you're going to get an and you're going to get an overlap. Just like that. Okay? So with this kind of problem, you might get an or, you might get an and. You don't know until you finish with both of these inequalities and you look at them and you say, all right, well, they're headed away from each other or they're headed towards each other. In this case, they're headed towards each other, so it's an and. And like all ands, you can write this as a three-part inequality. Say, all right, -3 is the low number, +6 is the high number, and the x goes in the middle, less than, less than. Now, if either one of these or both of these were closed circles, you'd have to underline, but they're not, so you're done. Okay? So we've got a couple things here. This is the solution, and this is the graph right here, the number line graph. How about this one here? So we want to graph the absolute value of x minus 7 greater than or equal to 7. Can I t-bar yet? And the answer is yeah. The absolute value bars are by themselves already, so go ahead and draw your t-bar. You don't have to get rid of anything outside of the bars like we did in the last problem. So go ahead and write x minus 7 is greater than or equal to 7. And on the other side, this part is still the same, x minus 7. But now two things change. The greater than or equal to becomes a less than or equal to, and the 7 becomes a -7. Both of those have to change. Now go ahead and solve them. Well, I'm going to add 7 to both sides. You get x is greater than or equal to 14. And you're going to add 7 to both sides here. If you add a 7 to this, -7 plus 7 is 0, so you get x is less than or equal to 0. And those are your two inequalities. Now the question is, are they going towards each other or away from each other? So let's say you have a number line here and another number line here. And let's see, this one is everything greater than 14. So let's say 14 is over here. We don't need to draw like every number on a number line, that's fine. And this is a closed circle, so closed circle, and we're going greater than, which means to the right. So this looks like this, 14 going to the right. This is 0, let's say 0 is over here. This is a closed circle, and it's less than, so we're going to the left. Are they going towards each other or away from each other? They're going away from each other. They're not going towards each other and intersecting. So this is an or, and with an or, you're going to pancake, like we learned yesterday. Just bring them down. So your answer, your graph will be 0 and 14, both with closed circles. Okay, the 14 going to the right, the 0 going to the left. There it is. That's your final answer. If you want to write a statement, it would be x is less than or equal to 0, or x is greater than or equal to 14. Okay, one more here. Now this one's got some stuff going on. This one's got a 2 and a 3 outside of the bars. We need to get rid of the stuff outside the bars before we can t-bar. So let's go ahead and do that. What do you get rid of first? Well, reverse PEMDAS. What can you add or subtract? Well, we can subtract the 2. That gets rid of that. This becomes this. And now we need to get rid of this 3. I can just distribute the 3, right? Wrong. You do not distribute into absolute value bars. You cannot get into prison or get out of prison. So you want to get rid of this 3, and it's 3 times the bars, so we'll divide. Divide this side by 3, divide this side by 3. Those will cancel out. We now have just the absolute value stuff. And this is 12 divided by 3, which is 4. Can I t-bar now? Yes, I can. Okay, so let's make some more room here. Maybe zoom in a bit. Okay, so I do recommend you watch these videos on a laptop rather than a phone, because you'll see more detail on a laptop or even an iPad or a Chromebook. So, okay, we're ready to t-bar. And on the left side of the t-bar, just write the entire inequality without the absolute value bars. And on the right side of the t-bar, well, you're going to flip the two things that we talked about before, which are this inequality becomes a greater than instead of a less than, and this becomes a -4 instead of a +4. All right, so let's solve these individually. We're going to subtract 4 from both sides, okay, and this becomes negative 2x is less than 0. And now we need to get rid of this negative 2, so we'll divide by a negative 2. I just divided by a negative, D-ban, which means that this is going to be x and this is going to be 0, but this inequality, because I divided by a negative, is going to flip, and instead of being a less than or equal to, it's going to become a greater than or equal to. All right, how about on this side? Do we D-ban on this side? Well, I've subtracted 4 from both sides. I haven't divided by anything, so I don't have to flip anything yet. And negative 4 minus 4 is negative 8. But now what am I dividing by? I'm dividing by a negative 2 again. So yeah, I'm going to D-ban here as well. Okay, divide by a negative. So that means this becomes x. This is going to flip, and that's going to be positive 4 right there. Okay, I have my two inequalities. Is it an and or is it an or? Well, let's find out. X is greater than or equal to 0. That's a closed circle on 0. That's shaded to the right, like that. And this is x is less than or equal to 4. So closed circle on 4 and shade to the left. So are they going towards each other or away from each other? Well, you can see they're on a crash course towards each other. If you put them on the same number line, they will crash into each other. So we have an and. That means we're going to bring down the circles here and look for the overlap. So this is your closed circle at 0. You have a closed circle at 4. And you can see the double shaded region, the overlapping region, is in the middle. And that's it. That's your graph. Now, if you want to write this as a three-part inequality, once again, take the low number, take the high number, put the x in between, and remember it's less than, less than. Since you're going from low to high, these have to be less thans. They're never greater thans. Now, do you have to underline these? Well, only if they're open circles. Sorry, closed circles. And yeah, they're both closed circles, so underline both. So there you go. There's your solution, and here's your graph. Okay, this last section here is about writing absolute value inequalities when you have an interval of numbers that you want to represent. So we're going to look at this example down here. We're going to do two things. First, we're going to write a three-part inequality for this and. This is obviously an and because the two sides are headed towards each other, right? And what would it be? Well, just like we did a few minutes ago, this would be x is greater than but not equal to 2 because it's a negative 2. It's an open circle, right? So negative 2. And x is everything less than but not equal to 10. So that would be an and statement. But they actually said use a three-part inequality. So we could do that by bringing down the low number, negative 2 and 10, the high number, putting the x in between, using a less than, using a less than. And neither one of these are closed circles, so we can leave them, we don't have to underline these. So that would be part A. Okay? But how can we write this as an absolute value? That's what we get when we solve an absolute value. But how can we get the absolute value? So here's what you do. You look for the center, okay, the center of the tolerance here. So this area here goes from 2 to 10. Where's the middle? Okay, it looks like 4, right? 4, 1, 2, 3 boxes to the right. Actually, it's 6 because it's going by 2s here. 2, 4, 6 to the right, 2, 4, 6 to the left. So your center is 4, okay? And that's going to go here in this formula that I have up here. It's going to be x minus the center, which is 4, is less than whatever the distance is in either direction, okay? Which is we established is going to be 2, 4, 6. So for part B, you're going to use this formula up here. It's x minus the center, x minus c, and then if it's an and, meaning they're going towards each other, this will be a less than. And you can see here, it says here, less than if it's an and, or greater than if it's an or. So it's all in the notes up here. Okay, hopefully you're taking notes as well. And this is going to be a less than. And what is the distance from the center? 2, 4, 6. We'll put a 6 here, and we'll put a 4 here. And that's it. Okay? You want to prove that this works, you can solve it. So really quickly, even though we're done, if I wanted to do the t-bar here, and I wanted to do the actual solution here, okay, I'm going to add 4 to both sides. I get x is less than 10. I'm going to add 4 to both sides here. Okay, negative 6 plus 4 is negative 2. X is greater than negative 2. So what I have here is, and it's backwards, but x is greater than -2, not equal to, so go in that way. X is less than 10, open circle going that way, and they meet in the middle. And you can see that's the same thing we have here, -2 and +10. So that does work right there. Now let me use blue there. So that does work. Okay. Once again, find the center. That will be your C. Find the distance from the center to either side. That will be your T. If they're going towards each other, use a less than. If they're going away from each other, use a greater than. Okay, for this last example, we're going to write an inequality, an absolute value inequality for what we see here. Now you can see the two sides of the inequality are going away from each other, so this is an OR. And for the OR, once again, here's the formula. Absolute value of x minus the center is going to be either less than or greater than the tolerance, the distance from the center to the edge. However, this is an OR, meaning they're going away from each other, so we use a greater than. Okay? So, if you're wondering what do I mean by a center, I mean in here, where is the center from here? So, we're going by 4s here. Let's see, this is -8 to +12, and where each box is a 4. Each tick mark on the number line here is 4. So this is 4 times 1, 2, 3, 4, 5. This is 20. So what I need is 10 from either side. So what we need is this, 2. Where am I getting 2 from? Well, I decided that this was 4, 4, 4, 4, and 4. That's 20. Divide that by 2, you get 10. And then, 10 away from 12 would be 2. And 10 away from -8 would also be 2. That's your C. And now how far are you? Once again, we said it already. It's from here to here to here is 10. And from here to here is also 10. So this is 2 and this is 10. That's it. So for part B, this is absolute value of x minus, well, C is 2, is greater than, because they're headed away from each other, 10. There you go, that's B. And if you were to solve this, you were to graph this rather, you would get this graph here. Now for part A, I wanted you to write it as an OR inequality. That's simple. You just look at it and say, all right, -8 is one of the numbers and you're less than that. So x is less than -8. It's also a closed circle, so less than or equal to. Or, okay, and then this is 12, so you're greater than 12. It's a closed circle, so greater than or equal to. So there's A and there's B. Okay, we're done. I'll see you at the next video.